I'm David. I'm from Facebook. I'm going to talk about trying to dump 150 people into one code base and making it scale. Specifically for Android, using a technique that we call Exopackage. Before I get into the details of what that is and how it works, I need to provide a little context about what it comes from, which is our build tool called Buck. This is a build tool for Android and other types of software that is developed at Facebook, but it's an open source project. You can find it on GitHub. A question you might have is, why did Facebook develop its own build tool? Why didn't you just use what was out there? So for those of you who are not super familiar with the Android build environment, here's a quick tour. One option that's out there is Ant. How many people use Ant for their Android builds? I see a couple hands. This is the official build system that's supported by Google for Android. Our experience with it was very slow. The other thing that we really didn't like about it is that it has very poor support for modularity. If you want a portion of your source code to be treated as an independent module, it has to basically have its own source tree. You have to update a lot of class paths. There's a lot of boilerplate. To give it a sense of our impression of the speed, one of our scripts, when we were converting to Buck, printed this message that said, you can download, install, and build this app with Buck in less time it would take you to just wait for this build to complete with Ant. That was very effective at getting people to switch over to use Buck. Another option is Gradle. How many people are using Gradle for their Android builds? A lot more hands. Awesome. So this is the beta build system that's provided by Google. It is not their officially supported option. It only recently went from good luck to beta a couple months ago at I/O. It's definitely faster than Ant. It still has pretty mediocre support for modules. You still need a separate source tree to get your source to be sort of treated as a separate unit. And if the question is, why didn't we use Gradle instead of Buck? Gradle didn't really have any meaningful Android support when we started, so it wasn't really a consideration for us. Now that Gradle does exist and has Android support, we could consider switching to it. But I hope the rest of this talk will convince you of why we don't think that's what we want to do. The other option is Maven. Does anyone use Maven for their Android builds? I see one hand in the back. This is not an officially supported thing from Google. It's extremely slow, and we don't like it at all. So that basically led us to create Buck. We were using Ant. We were doing what Kieran referred to as mobilization. We were getting more people developing native code on Android. The builds were getting slower with Ant. We have a lot of engineers. They write a lot of code. The main Facebook for Android app has over 650,000 lines of code. That's a pretty conservative estimate. That's the number of executable lines of code in our production release build. So depending on how you count, that number could be higher. And Buck helps us build it quickly. But a lot of the optimizations that Buck does for our large app will also work for smaller apps. And I have some numbers on that in a little bit. So as you might have guessed, Buck's focus is speed. We've seen about a 10x improvement in the median build time of our main Facebook app over the last year. So this is not comparing Ant to Buck. This is just comparing Buck from a year ago to Buck now. And this does not control for the size of the app. Obviously, our app has increased in size during that time, but still the overall absolute median build time has gone down about 10x. We have a lot of important optimizations that allow this to happen. The first one, which has really been in Buck since the beginning, is that it has good support for high granularity modules. We have one unified source tree for all of our Java code, and individual parts of it can be made into sort of standalone modules that get built independently just by dropping a Buck file into that directory. So in many cases, an individual Java package gets compiled as a separate unit. This also allows us to do a lot of parallelism in our builds because each module can be compiled in parallel. We do what we call an ABI optimization. So if you do a build and then you change some Java code and build again, Buck is able to detect whether you change the interface of the module or just the implementation. And if you only change the implementation, we don't have to recompile any of the other Java code that depends on the part that you changed. When you build an Android app, your Java files are compiled to class files. That's a standard Java thing. And then before those class files can run on an Android device, they have to be converted into a different format, which is called DEX. Android has a tool called DX that does this. And then at the end of your build, you merge all those DEX files together. And DX does have support for this, but it's relatively slow. So Buck has a custom version of DX in it that has a much faster algorithm for doing the merging. We run Buck as a daemon. Gradle also has this option, but it's not enabled by default. It basically means that you run Buck and it stays around in the background and it's ready for you to do your next build. This is a big help for build tools that are written in Java themselves, so specifically Java-C, the Java compiler, and DX, which creates those DEX files. Those are both written in Java, and by keeping them resident in memory, we get to preserve the work that Hotspot did to JIT that code during your first build, and then when you do your second build, it's already pre-JITted. So this has a huge impact. It depends on the build specifically, but I've seen this have a 3x impact increase in build speed from doing the exact same build, the exact same work, just by having the stuff pre-JITted versus not pre-JITted. The last major optimization in this first generation is a distributed cache. So we have these high granularity modules that are always being built by our continuous integration server, and it uploads those results to a distributed cache. And then individual developers, when they do their builds, they don't have to rebuild all that stuff from scratch. They just pull down those cache results. So if you have been away from the office for a week, you check out the latest master and do a build. If you're in the office, it can take 20 seconds or less to do that full build. Even though you have nothing local, it just pulls it all down from the distributed cache. So these are a bunch of improvements. These helped our times a lot. Once they were all done, what was still slowing us down? Well, we identified two big things that were still problematic. And those are ApkBuilder and the installation process. So ApkBuilder is part of the Android SDK. If you use Gradle, this is what's referred to as the package debug step. And it's basically a process that takes your assets, your DEX, which is your compiled Java code, and your native libraries, and just sort of smushes them all into one file, which is your APK. That's the final app that you install on your device. This can take 7 seconds or more for large apps. It's basically just proportional to the size of your app, because it just has to cram a bunch of files together. The next step that's really slow is the actual installation of that app onto a device. So this is done over ADB, and the ADB protocol maxes out at around 5 to 6 megabytes per second, even if you're on high-speed USB. So if you have a 20 or 40 megabyte debug build of your app, this can take a very long time just to copy it over. Once it's already there, the package manager has a lot of work to do. It has to copy the APK into place. It optimizes your DEX. It expands your native libraries. It verifies signatures. I don't know what else it does. It takes a really long time. This entire process can take anywhere from 2 to 45 seconds, depending on the size of your app and whether you're using a physical device or an emulator. The physical devices take longer than high-speed emulators. So this totally sucks. Our developers are really unhappy about waiting this amount of time after they make a one-line change to see that code running on the device. They hate waiting. So to explain how we avoid these steps, I have to take a quick digression. How many people are familiar with the 64K DEX method limit by show of hands? A decent number. How many of you were happy to learn about this when you first did? I see more than I expected. Wow. I was certainly not happy when I learned about it. Basically, when DX combines your class files into this DEX file, every method in your app needs to be assigned a unique 16-bit identifier. And if you have more than 65,000 or so of these identifiers, it just throws up its hands and says, I can't build your app. And you see Stack Overflow posts and bugs filed against the Android open source project. DX crashes on projects with greater than 65,535 methods. That's basically the long and the short of it. The important thing to realize is this isn't just methods that you define. It's any method in the framework that you reference. Anywhere in your app needs to be given an ID. So for example, if you look at this little snippet of code, we have one method being defined here. There are actually 8 method references on this slide. I challenge you to try to count them. I got 7 right and 1 wrong when I tried this. The point is that they can sort of sneak in where you don't expect them. Another thing that can cause your method reference count to go up really quickly is importing any third-party libraries. They tend to have a lot of features. You might not be using all of it. So for example, if you want to do something as simple as receiving push notifications in your app, you'll go to the Android developer documentation site. It'll say, oh, you need to use Google Play Services in your app. Put these 2 lines in your build.gradle file. This adds 29,335 method references just from these 2 dependencies. If you actually do this, you'll see your count go up by a smaller amount than that, because some of that overlaps with what your app is already likely to be using. But the fact that just using push notifications basically takes you halfway to the cliff from 0 is not really a good sign. So there's a couple ways to mitigate this. One that's very common is ProGuard. ProGuard will find bits of your app that are not referenced and strip them out automatically. This is extremely effective for third-party libraries because if you're only using a small piece, there's a lot of stuff that's unreferenced that can be removed. The bad news is that ProGuard is a little bit slow, even in its most simple stripping modes. So you really don't want to be running this on every single debug build. It'll slow you down a lot. Another option is secondary dex files. How many people have tried out secondary dex files in your apps? I see a few hands. There's this blog post from 2011 where people were apparently already hitting this issue that explains how you can pull some of your code into a separate dex file and they get separate IDs. You load them at runtime with reflection. It's a little bit inconvenient. So we dealt with all this at Facebook a while ago. The support that we built into Buck, basically what it does is it takes, use this fancy laser pointer. It takes all your classes that are supposed to go into your app and splits them up into different sections. So you have this little one at the top, which is your bootstrap code. That's what's necessary for loading up these secondary files, and puts the others into these chunks that are sort of independent. They all get converted into this DEX format independently and then get packaged into the APK. So the bootloader code becomes your main classes.dex, and the secondary DEX files become these assets. That whole thing gets copied onto the device. So that was how we got around the DEX method limit. That was built into Buck a while ago. And while it seems unrelated, it's actually sort of the secret of how we were able to speed up these builds by a substantial margin. So here's a zoom in on the two steps I was talking about before. ApkBuilder on the left, where you're producing the APK, and installation on the right, where you're putting it on the device. This is the before picture. And the sort of magic sauce of Exopackage. It sounds very simple. It looks like this. Basically, the secondary DEX files get removed from the APK. They don't go into the package at all. The APK only contains your classes.dex, your bootloader code, and also your native libraries and resources. That gets installed the same way it always did. And your secondary DEX files, which contain the bulk of your Java code, get side-loaded onto the device through a separate mechanism that doesn't go through the package manager. It does still go through ADB. And this is an optimization we do on debug builds only. Obviously, you can't just like send these secondary files to users' devices. But for debug builds, it's very easy to just install it directly on the device. So this is obviously a very simple change, but it has a huge impact on the performance. The ApkBuilder step is only necessary if you change something that actually goes into the APK. So this is your assets, your native code, or your bootstrap code. If none of those change, if you're only changing your sort of run-of-the-mill Java code, you can skip the ApkBuilder step entirely. And that saves you about 7 seconds. The other thing is that the installer is relatively smart. It'll only install the files that actually changed since your last installation. So if you didn't rebuild the APK, that means you also don't need to install the APK. You can skip the package manager entirely if you're only changing your Java code. And this has an even bigger effect if you're using Art, because on Art, it does a lot more pre-optimization during the installation. And if you can install a smaller part of your app, then you can skip some of that pre-optimization and your install goes even faster. And so the other thing is that in our production app, we sort of artificially reduce the size of these DEX files and increase their number so that when you only change one, only that one needs to be reinstalled. And so instead of copying over all of your DEX files, we can only copy over maybe 10% of the content, which takes about 10% of the time. The result of this is that it is absolutely possible to achieve a 4-second build plus install time with Buck, even with a relatively large app. So this is not our average build time. It's substantially larger than that. But you can definitely, if you're iterating on a bit of Java code that's in a relatively small module, you can see this very frequently, 4-second build and install time. And that has a really dramatic impact on the way you develop code when you can iterate that quickly, making changes. In practice, we see about 60% of the time we're able to take the fast path of installation and skip the APK install entirely. There are a lot of cases that cause you to have to reinstall the APK if you are changing any XML, if you're changing any native code, if you rebased and you pulled in a bunch of days worth of changes from your code developers who changed XML code, if you grabbed a new device that hasn't had an install in a while. But even being able to eliminate the slow path in 60% of cases is a really big win for us. So FBFray is a relatively big app. What about a smaller app? There is an open source podcast app for Android called AntennaPod, which is a fantastic app, by the way, if you're interested. As a demonstration of this stuff, we ported its build from Gradle to Buck and did some apples-to-apples comparison. And basically what we saw was that with Gradle, this relatively small app, this 30,000 to 40,000 lines of code, had about a 20-second incremental build plus install time, whereas with Buck, it was about 3.2 seconds. And as your app gets bigger, that number on the left is obviously going to go up. Your builds take longer, your installs take longer. The great thing about the way Buck does DEX merging and Exopackage and all these other optimizations is that the number on the right stays relatively constant. For Facebook for Android, it's more like in the 5 to 6 second range. But for an app that's substantially larger, that's not that big a difference. In the future, one of the issues with Exopackage right now is that it only pulls your Java code out of the APK. If you make any changes to native libraries, images, XML layouts, those still require an APK installation. I'd love to see the native libraries and images pulled out of the APK so that the resulting APK is a lot smaller, and so even when you do have to install it, it's a lot faster to install. The other thing that would be really cool is if we could do something like Exopackage for XML layouts. It's a lot more complicated because of the way the layout inflator handles tracking where these things came from, but it could be a huge productivity boost for the people who are editing XML. So if you want to learn more, Buck is on GitHub. There's an article that's specifically about Exopackage and how it works, and has like a step-by-step walkthrough of how we ported AntennaPod to Buck and got Exopackage working with code, so you can replicate this experiment or try it on your own code base. That's all I got.
So, why don't we take a few questions while Paul comes up to give his talk. Hey, Paul. So questions? Right over here. I was blinded.
Sorry. Do you have a plan to integrate those very cool technology into Gradle so that most people who still use Gradle can benefit from your technology?
I think the thing that we're more interested in is making the things that are convenient about using Gradle work in Buck so that people can port to Buck. I didn't actually anticipate this question. There are a couple of issues that are difficult. One is that the multi-dex support is actually a much more complicated change to the way Buck works than the Exopackage stuff. I think getting that to work in Gradle would be a lot of work, and the later optimizations like Exopackage aren't really that beneficial until you can get those earlier ones right. And the second issue is that the smart installer that actually sees what you actually have already installed is it's pretty important for that to work properly in order for this optimization to work. And that is another chunk of code that would have to be ported into Gradle. It would have to sort of know about the process of installing onto a device in a way that it doesn't right now.
Cool. Right here.
You ready? Oh, okay.
Hey, I wonder if you've put any effort into NDK support for native libraries?
Yeah, so we don't do that much native code at Facebook. We do some, and so the native support in Buck is lagging a bit behind. We're trying to improve that, and one of the things that I think would be really cool for us to do is, like I said, pull the native libraries out of the APK, just like we did with the secondary DEX files. That's actually it's probably easier to do than it was with the DEX files, and once we get that, you could basically get into a state where you are basically rsyncing your native libraries onto the device. You don't touch the APK, you don't touch the DEX files at all. That's if you're just developing the native code. And so I think it is possible to see times like this with native code with those optimizations.
Any other questions? Are you ready to go up there?
I think so.
Okay.
All right, thanks a lot.